A disk of mass m is moving horizontally to the right with speed v on a table with negligible friction when it collides with a second disk of mass 2m. The second disk is moving horizontally to the right with speed v over 2 at the moment before impact. The two disks stick together upon impact. What is the kinetic energy of the composite body immediately after the collision? So, we can use the law of momentum conservation after this. And the law of momentum conservation states that the momentum of a system always stays the same. So before the collision, it has certain momentum, like two objects can have a certain momentum. And after the collision, if they stick together, they're going to still have the same momentum. And since they're sticking together, this is an inelastic collision, and the momentum will be the sum of the masses times the velocity of the combined items. So, can represent this, we know that momentum is the mass times the velocity. So the momentum of the first disk is just mass times velocity. The momentum of the second disk is 2 times the mass times the velocity over 2. And that is the momentum before the collision. After the collision, after they stick together, they have a combined mass of the mass of the first disk plus the mass of the second disk, and then times the velocity of the composite body. So we already know all of the masses. We just need to solve for the velocity of the composite body first. And then we can just use a bit of algebra to simplify this. The 2's cancel, and then you can add the masses together. Then you can simplify so that the velocity of the composite body is equal to 2mv over 3m. M's cancel, so the velocity of the composite body is 2/3 of the velocity of the first disk. And then now we need to plug this value into the formula for kinetic energy. We know the mass, and now we can plug in the velocity in terms of the first disk. So the kinetic energy is equal to 1/2 of the total mass. This is after the collision, so you have to remember this is the total mass of 3m. And then times the final velocity after the collision, which is 2/3 of the velocity of the first disk initially, squared. And then now you can just simplify this to the kinetic energy is equal to 3 over 2m times 4 over 9v squared. And then, so this gives you a final kinetic energy of 2/3 mv squared. And that is in terms of the variables of the first disk. And that is how you solve this problem.